Hello everyone, welcome back on the series of differential equations. So let us start. Before starting, I would like to introduce some concepts and definitions or the terminologies like you have heard about variables, independent variables, dependent variables, and parameters or arbitrary constants. So you might be familiar with the concept of function and relations and sets. So let us define what do we mean by a function. What is a function? So let us define it in loosely speaking. We can say a function from a set, this be a set and this be another set. Let it be B and this be A. So a function from set A to set B is a rule which assigns a unique element of the set B for every element of A. Okay, that is, these are books. So this be 1, 2, 3, and 4, 5, and these be students. Uh, Anything 1, 2, 3, 4, 5. So what it means that for every book we assign a student, and that student will be unique. This means if I assign book 1 to student 2, and then this book will not be assigned to any of those 1, 3, 4, or 5. And for every book we must have a student. That is, we should, for this book also we have one student. This means one book cannot be assigned to more than one student. Okay, so it is crude definition. Now we define what do we mean by variables, independent variables, and parameter. So let us take a simpler look. Let this be a triangle. Okay, this be our coordinate system, this be x and this be y. Okay, now what do? We make a triangle. Okay, and it's this side be y and this side be x and this side be y. Okay, and let this angle be some any angle, let's say alpha. Okay, so now consider the area of this triangle. So we know the area is 1 by 2 half base into height, 1 by 2 x into y. So this area is function of x and y, that is x and y. Now what can we do? We can take any arbitrary value of this x and any arbitrary value of this y, whatever we want. According to our desire we can take or put any value to x and y. So these x and y are called independent variables. And area also varies. As we vary x or y, area also varies, but area cannot take any value. The value of area depends on the values of these x and y. So this area is called a dependent variable. Dependent variable. Whether these x and y are called independent variable. And this angle, look at this angle. If we do not change this arbitrary angle, then what do we say? What will we see if we increase x, and for that x we should have this y, and similarly if let this be x1, and then this be y1, and this be x2, and this be y2. So if we do not change this angle alpha, then these all triangles will be similar and have looking similar, and these triangles are also called similar triangles. But if we change this arbitrary angle alpha, then the type and shape of the triangle also changes. So this angle alpha is called a parameter or an arbitrary constant. Okay, hopefully you will understand these things when we would be talking about the differential equations. It is similar like that. If we change the arbitrary constant in the solution of a differential equation, so the type of solution changes. Okay, so now we define what do we mean by a differential equation. So differential equation. Differential equation is nothing but, so before that I think you would be familiar with the rate of change or the derivative of dependent variable with respect to independent variable. So a differential equation is nothing but a function of dependent variable, independent variable, and derivative of the dependent variable with respect to independent variables. Just like in this case the area of triangle, there are two independent variables. So the independent variables may be more than one, and the dependent variables may also be more than one or one. So a differential equation is, let y1 of x, y1 of, let y1, y2, y3 be dependent variable, and x1, x2, x3, so on be, and yn and xn be, these be independent variable and these be dependent variable. So what is a differential equation? So a function of this type x1, x2, xn, and y1, y2, y3, as I said that it is function of dependent variable, independent variable, these are dependent variable, these are independent variable, and derivative of the dependent variables with respect to independent variable. So dy1 upon dx1, similarly dy1 upon dx2, and so on, dy1 upon dxn, and differential or the derivative of this variable also with respect to independent variables. So this will be dy2 upon dx1 and dy2 upon dx2, and so on. Similarly for dyn upon dx1, dx1 and dyn upon dx2, so on, dyn upon dxn, and also any power of this derivative. So let its power be some m1, and its power be some m2, its power be some m3. So what is a differential equation? A differential equation is nothing but a function of dependent variable, independent variable, and derivative of dependent variables with respect to independent variables, with any power, with any degree or the power. So let a differential equation be simple. This is indifferent. Here we have n dependent and n independent variables, but look at some simple cases. Let x be independent variable, y be dependent variable, and dy by dx be its first derivative, and d2y by dx2 be its second derivative, and let its power be m, and its power be n, m1 its be m2, and similarly dny upon dxn. What is it? This is nth derivative of y with respect to x. Okay, let its power be mn. So now how do we define the a differential equation in what is the power or what is the order of differential equation, and what is the degree of differential equation, and what are called the ordinary differential equations, and what are called partial differential equations. So let us talk about ordinary differential equations. So in this case, we have dy by, we have only one independent variable, so ordinary differential equation, ODE. In ordinary differential equation, is a function of dependent variable, comma independent variable, and its and derivative of dependent variable with respect to independent variable. But what should be the case? We have only one independent variable, whether the number of dependent variable may be one or more. Okay, so for the ordinary differential equation we have only one independent variable, means we have only, just like in this case we have, these are independent variables, but for the ordinary differential equation we have only one independent variable. Let's say it x1, not these all. Okay, so when, as I have said, that the number of dependent variables may be one or more. If we have more than one dependent variable, more than one dependent variable, then we say that system of ordinary differential equation. Then we say system of ordinary differential equations. Similarly, if a differential equation is such that it contains more than one independent variables and derivative of dependent variables with respect to independent variables. This means when more than one independent variables, what do we call a partial differential equation. Equation. So let us understand this by a simple task or a simple example or daily life example. Let us consider that I said you to make something or something dish, just as uh, if I say you give me 1 cup of tea, then what will you do? For that purpose you will take a bowl and some water and milk and tea and sugar and ginger and so on, etc. So our is tea is a function of in that case our tea is function of what? Water, milk, ginger, sugar, and also some more things. But if I say that how can you change the taste of tea, then in that case, then for changing the taste you can vary any of this: water, milk, ginger, sugar, and tea. So then how can you represent? Let this be T, so and this be W and M, G and S. So our T is function of W, S, G and S and small t. So for that purpose what can we do? We can change everything in one way or once. Then you will not be able to tell that what is effect of changing the water, what is the effect of changing the milk, what is the effect of changing ginger or sugar. So for that purpose what will we do? Once we keep all these things constant or will not change sugar, ginger and what milk, and we'll change only water, then that we will rate of change of the taste of tea with respect to water we will write as del T by del W, and all these things are constant, that is S, G, M and T. And similarly for when we change only milk, then all these things should must be constant, because if we change all things at once we will not be able to tell what is the effect of change of this thing or that. So such differential equation, in such case the differential equation will be a partial differential equation. But when we have only one variable, one dependent variable and one independent variable, in case of one independent variable we have only one, so we don't worry about the other things.